The last video ended up with me giving you this OR gate and asking you what the minimum set of test vectors would be. And if you worked it out, you'd start out with a stuck at 0 and a stuck at 1 at A, a stuck at 0 and a stuck at 1 at B, a stuck at 0 and a stuck at 1 at the output. And you'd have to find inputs to test each one of those. And if you went through the same steps that we went through, oh, my mouse is a mess, for the AND gate, where you started out with this large table and then you reduced things down by seeing that, hey, you can do a stuck at 0 at A, stuck at 0 at B, and a stuck at 0 at the output by this one test. When you went through that and made sure all the faults were covered, you ended up with these 3 test vectors. For the OR gate, if you go through those same steps, you end up with these 3 test vectors. So with A is 0 and B is 0, it checks for a stuck at 1 fault at A, B, and the output. So this actually takes care of 3 tests right here. It takes care of all the stuck at 1 fault possibilities there are. This tests for a stuck at 0 at A or the output, and this one tests for a stuck at 0 at B or the output. Ask me if you have any questions about those. Okay, and then we have the AND table that we already looked at. So even now that you have for every single gate, you've got it down to 3 tests to exhaustively. That's when we were talking about exhaustive testing, when we test every single fault that you could have. Test it for every single fault you could have. If you have 600,000 gates, still that's 3 per gate. That's 1.8 million tests. So that's still a lot. So actually, when you put these into a circuit, you can reduce the number of tests even more. So let's put the AND gates and the OR gates into a larger circuit and figure out what the test vectors would be. So here's a larger circuit, and if you put in all the stuck at faults, just like we did with when we were testing an individual gate, you start out with all the faults that you could have on an individual gate, which means on each input you have a stuck at 0 and a stuck at 1 possibility for a fault. And so both of these inputs have stuck at 0, stuck at 1. Same thing down here, stuck at 0, stuck at 1. And then you also have to check the output for stuck at 0 and stuck at 1. Then for the AND gate, you do that too. You completely populate it. So every single gate has 6 tests around it. And as you can guess, you can reduce this down. Like a simple reduction here is that if you're checking this wire for a stuck at 0 fault right here, you can't tell that, you can't differentiate that from a stuck at 0 fault here. Anywhere along this wire, if there's a stuck at 0 fault, it's a stuck at 0 fault. So having a stuck at 0 fault check here and a stuck at 0 fault check here, that's going to be the exact same test. And so you only need to really have one of these on line. So you can get rid of 2 of those. Let's see what else you can do. If you remember, for an OR gate, to completely test an OR gate, you can test for a stuck at 1 fault at A, B, or the output. No matter which one of these stuck at 1 faults you're testing, you give it the same input and look for the same output. So you can just say, okay, oops. And then for the stuck at 0, you have to test for stuck at 0 at A. You have to test for a stuck at 0 fault at A. And for B, you have to test for a stuck at 0 fault at B. But doing either one of those tests also tests for a stuck at 0 fault on the output. Oops. Stuck at 0 fault. Testing for a stuck at 0 on the inputs gets rid of a stuck at 0 fault. Also test for a stuck at 0 fault on the output. And then you can do the same down here. Okay. And then for the AND gate, remember if you check for a stuck at 0, you can check for a stuck at 0 any place. So I'm going to check for that in the output. And then for checking it as stuck at 1, you need to test for a stuck at 1 on each input for an AND gate. And you don't need to have 2 of the same tests on any wire. So you only need a stuck at 1 here or a stuck at 1 here. So you can cross one of those out. And then since you're testing for a stuck at 1 here, remember any test that tests for a stuck at 1 at the input also tests for a stuck at 1 at the output. So if you test for either one of these inputs, then you don't need the stuck at 1 test at the output. Okay, so now we started out with 6 per gate, so 18 total. We just got rid of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So now we're down to 7. Okay. One thing here that's the most tricky part of finding the test vector to test this is if you're testing for a stuck at 0 fault, you're also testing for a stuck at 0 fault on this wire. So if you're testing for a stuck at 0 fault on the input of your OR gates, you're already testing for a stuck at 0 fault on the output of the OR gate, which, because it's on the same wire, you're also doing a stuck at 0 test on the input of the AND gate. If you remember, a stuck at 0 fault test for a stuck at 0 at A, a stuck at 0 at B, and a stuck at 0 at the output, that's the same test. So if you're already testing for a stuck at 0 on this input, you don't need it on the output anymore, and you can get rid of that last test. That's the trickiest part here. And ask if that didn't make sense. So now you started out with 6 per gate, so 18, and now you're down to 2, 4, 6 tests total. So if you reduce the number of tests by 2/3, and you're still exhaustively testing your circuit. Okay, so we ended up with these tests right here, these 6 tests to completely cover this circuit. Now, next step is, it's really hard for humans to see exactly, the inputs by just just looking at this circuit. So putting it into a table, and if you notice, we have to test for a stuck at 0 fault at A on this OR gate, and remember, we can only set the inputs and watch the output. So if we're testing for this stuck at 0 fault at A, we need to make sure that some signal goes all the way to the output that tells us if there was a stuck at 0 fault at A. So let's look at what I have here. So the first gate is an OR gate. So if I put a 1 on A and a 0 on B, if there's a stuck at 0, I'll get a 0 at the output. If there's a stuck at 0 at A, I'll get a 0 at the output. Now, I need to be able to look it out and tell whether that was a 0 or a 1. So if you remember, on the AND gate, then I have to have a 1 on this side. So I need either C or D to be 1. And if C or D is 1, then there'll be a 1 here, and then whatever the output of this OR gate, it will get passed through. If you have a 1 on this input and A is 0, then you'll get a 0 on the output. If you have a 1 on this input and B is 0, and A is 1, then you'll get a 1 on the output. So to pass this output through, you need 1 on there, and that's what setting C or D to 1 is. And then you have the same test on B and C and D. So each one of those, to pass the signal through, you need the other wire to be 1 when you're passing this signal through. And you need this wire to be 1 when you're passing this signal through. Okay, and then you had a stuck at 1 fault test on this wire and a stuck at 1 fault test on this wire. If you're testing for a stuck at 1 fault on this wire, that means you have to try to set it to 0, which means both A and B have to be 0. And then down here, if you're checking for a stuck at 1 fault on this wire, you need to try to set it to 0. That means C and D both have to be 0, and that's what's happening here. And then to pass that value through, you need this wire to be 1, and that's why either C or D has to be 1 here, or A and B has to be 1 here. Okay, so now we have a new table, and I don't remember if this is animated. Yes, it is. Okay, so we look at one of the tests here. You have 101 don't care, and you see if that can overlap with anything without having a conflict. See if you can do two or more of these tests with this one test vector. So this has 1011 don't care. You can see that this second test right here, 10 don't care 1, you could use the test vector 1011 and it would satisfy both of these. The thing is that you don't really care about that. If you're doing this test, you're testing for the same fault, so you only really need to do one test. So when you do this circle, you're not looking to merge the exact same test. You're looking to merge some other test, like on a different input or on an output. So let's see if this can merge with anything. Can't merge with either of these because this needs A to be 1 and B to be 0, so it can't merge with that. What about this line right here? You have a 1 on A, you have a don't care on B, so you could make that 0. And then you have a 1 on C and a 0 on D, and you have a don't care here. So those two right there, if you used 1010, you could do both of these tests at the same time. And you also have to check to make sure the output's the same. See if there's any more. So now, if you're using this test, then you don't need to do this because it's testing for the exact same thing, exact same fault. And you do need that one, but it's combined with this one. So this test is already being done by that, which means that, okay. And then you go to the next line and you're looking for anything that, see if you can do two tests with the same input. So that's 0, 1, 1, don't care. And you have a, and then, there were none that matched this. 0, 1, yeah, there were none that matched this, so that was all by itself. But if we decide on doing this test, we don't need to do test number 4 because that's the same test that we've decided the circle here says we've decided to do. Okay, and then C got crossed out because it's covered by 1010. So this test is already being done. If it's already being done, then you don't need its duplicate. You go down to D. You look for anything that can be merged with this. I don't see anything, so that's alone. But if you're doing this test, then you don't need this duplicate test here. Do that, then you don't need any. Then you can't merge it, and you don't need this second test. And you went down and forth. So we had 1, 2, 3, 4, 5, 6 tests we said we had to do. And now we have 1, 2, 3, 4, 5 because this test was merged with test 5. So we got rid of one more test. It's really hard to figure out. I know that was a really lousy explanation. Ask me if it doesn't make sense. But it's really hard just to look at this table and see when you can merge tests, when you can do 2 stuck-at tests with a single vector. So we use a merger graph. Now, if you look at this merger graph, we know test A and B are testing for the same fault. So that's test 1 and 2. They're doing the same, testing for the same fault. So I connected 1 and 2 with a dotted line. Okay, and then you also saw that 1 and 5 can be merged. If you use the test vector 1, 0, 1, 0, that covers the 5th test and the 1st test. So we can use a single test vector to test 2 of them. I connected the ones that you can use a single test vector to test both tests. I connected them with a solid line. Okay, so let's look at that. 1 and 2, 3 and 4, 5 and 6, 7 and 8, 9 and 10, and 11 and 12. Those are the same tests, so they're all connected with the dotted line. Okay. And then 1 and 5, those can be merged into 1, 0, 1, 0. Let's see, I have that 2 and 7 can be merged. So let's see, 1, 0, don't care 1, 1, 0, don't care 1. So 2 and 7 can be merged, so I connected them with a solid line. 3 and 6 can be merged. So 0, 1, 1, don't care. 0, 1, 1, 0. So if you use the test vector 0, 1, 1, 0, that satisfies a stuck at 0 on C and a stuck at 0 at B. So that's by a solid line, and then 4 and 8 can be merged. Okay, so the next step is saying, okay, I want to merge as many tests as possible to get rid of, if we can duplicate, if we can use a single test vector to cover 2 faults, then that means that you don't have to do 2 separate tests. You can do 1 test and test for two faults. That's a good thing. So let's go back, and let's say I pick 2 and 7. All right, so 2 and 7, I can merge those into a single test, and that means I'm doing this test number 2 and I'm doing the test number 7. If I'm doing that, then if you noticed, test 7 and 8 are the same test, but if I'm already doing 7, I don't need to do 8, so I can cross out 8. And same thing here, if I do test 2, then since test 1 and 2 are testing for the same fault, I don't need to do test 1 anymore, so I can cross that out. And then I'm going to circle 3 and 6. Those can be merged. They're connected with a solid line. So I test 3 and 6. I can use 1 test vector to test both of those. But if I'm doing test 3, I don't need to do test 4 because test 4 is testing for the same fault. So I can cross that out. And then also with 6, if I'm doing test 6, that's the same test, testing for the same fault as test 5, so I can cross out 5. Okay. And then, so let's see. And then these 2 are testing for the same fault. They're a different test vector, but testing for the same fault. So I only need to do 1 of each of those, and I can cross out the other fault. If I'm doing 11, I don't need to do 12. And if I'm doing 10, I don't need to do 9. So what's happening here is now I have only 4 tests I need to do. So we started out with 18, and now to exhaustively, completely test for stuck-at faults on that 3-gate circuit, I am now down to 4 tests. Okay. And I have a practice circuit on here. This is pretty challenging and gets kind of messy, but I have that animated if you want to go look at how that went. And it goes into the table and then into the merger graph. So those are the steps if you want to test with a minimal set of test vectors and a gate circuit, a circuit made out of gates. If you want to test it with the minimum number of tests, you reduce the number of stuck-at faults, you make a table, and you make a merger graph, and try to combine as many tests as possible.